Welcome to the Insights for ArcGIS Advanced Edition. This is the last Insights session that I know about this week.
Oh, there's a secret one you don't know about.
That really. Figures, they never tell me anything. So today we're here to talk about advanced topics within Insights. So if you attended the introduction, that's a perfect prerequisite for this class. If you didn't, that's okay. We'll test you at the end. All right, so my name is Art Haddad, and I'm Art. And this is Linda Beal, my colleague.
Hi.
She doesn't stand up.
No.
And we're here to talk about this.
I'm sitting comfortably and my microphone's not buzzing, so I'm just staying right here.
There you go. So let's go ahead and get started. We have 60 minutes together and we have a lot of material. So we're going to try to get through all of it and still have time for questions at the end. Ready? Set? Take it away.
Okay, analysis. Traditionally, it's always started with a really sort of well-framed question. We know the question that we want to ask of the data. We then go out, we collect that data, either finding the files or we go out in the field, collect the data, and then we come back and so we've got our theory, we've got what we're observing in the data, and then we test the hypothesis from that. Well, now we're finding things are changing a lot. So data is being collected all the time. It's being collected by our companies. It's being collected digitally. And now people are asking us, the analysts, to find the answer in the data. So we're kind of on the back foot a little bit. You know, here's the data, so give us the answer. Okay, so now we've got to find what the data can show us, what questions we can ask of that data, what makes sense from that data, and then find the answer for them as well. And of course, we probably have less time and less money, but that's a whole different story. So we kind of shifted from this kind of deductive theory, from where we understand the theory, we observe what we can in our data, we develop our hypothesis, and then we prove or reject the hypothesis that we've got. Or reject, I should say. Inductive is a little bit more how things are tending to go. So we have the data, we're observing what we can in that data. We then, from that, can start to develop the theories in it and pulling out the hypothesis as part of we go. So both of them are allowed within science. They're both perfectly good scientific methods. It's just with one, we're starting with the theories. In the other, we're observing it and pulling out the science from that and developing the hypothesis and theories from that. In fact, the reality is it's a little bit of both. We're doing a little bit of both in it. But the point of this is that really we need to understand both the analysis that we can do, that can be done, but also the data that we have and that intersection between the two. What makes sense, what questions can be asked of this data? Over to you.
Yeah, it's kind of like, here's the data, now go do that data science-y thing, right? But in order to do that data science-y thing, you need the right technology to be able to support that thing. And to do that, Insights, the technology itself has evolved. It's what I lovingly call Moore's Law meets Darwinian theory of software evolution. To match the analysis that we're requested to be doing with the types of data and the complexity of said data, we have to change the way we do the back end. So unlike traditional apps, this is not a simple browser-based, JavaScript-based application. In fact, it's a full stack. And it begins with a new technology that we included with the ArcGIS system known as the Insights service. What we really want to do is allow the browser to do that simple drag and drop thing. So from a user perspective, you're focused on the analytics. But behind the scenes, there's probably 6 or 7 things happening simultaneously. And that is sent down to this Insights service, which acts as more of an orchestration engine, kind of like a coordinator. It takes that tool chain, splits it apart, and works with the multiple data engines in a very parallelized way. Not only is it at the server level, but we also have to work with data. So we have to send the compute as close to the data as possible to be able to get you the type of performance working with the entirety of the data set, such that you get an accurate answer to your analytic question based on that simple drag and drop. And because of the complexity of data, it's never in one place. It's across multiple sources. So the Insights technology, think of it as a complete system within the system. has to work across all tiers of data. And that's how we're going to achieve the types of analytic workflows that we're trying to express through the user experience in a very easy way. Keep in mind the technology should fade away in the background so the analyst focuses back on the analysis that needs to be done based on both deductive and inductive thinking. So, for a lot of those reasons, the first step is to understand how we work with the data. And in Insights, the minute you add a data set, regardless of the data source, we dynamically infer what the data is. We identify categories, we identify numeric, we identify temporal, and the spatial dimension. And we articulate that in the data pane, as you see here with these icons. You start seeing the location field, you start seeing a numeric field, categorical, and date and time. And because Insights, keep in mind, we're only 17 months old, right? So we're really into this modern way of thinking around analysis. One of the key things that analysts always do is they always use calculated fields to come up with information based on the data that they have. Or they try to pre-process information, like date and time, into its constituent parts. So a lot of the analysis, if you think about it, well, what is the word? 80% data wrangling? We try to take care of a lot of that behind the scenes for you. For instance, breaking apart those constituent components of a date and time field, we do that automagically. Yes, that is a word, automagic.
Well, it is now.
It is, well, yeah, I've been talking to Webster, but we'll see. Year, quarter, all the way down to the minute. We actually do that behind the scenes for you. And because we do that, that saves a bunch of time. But it's not just at the semantic modeling of your data, dynamically, I might add. It's also in the way that you work with the results of your analysis. Those results are actually given back to you as additional data that you didn't once have. Think about a pivot table. When you're pivoting a piece of the data, it gives you a whole new set of information, and that information is then added back for you to perform analysis. And we try to make it easy to understand where those results come from by lining it up and indicating it with connections back to the origin source. We even take it a step further and give you a hierarchy, so that if it's a data set that was derived from another one, it's listed directly underneath that data set. If it's a data set that produces a new set of results, then it's at the same level as the origin data set. But it's more than that. It's not just about visualizations with Insights. Keep in mind it's about analysis. And because it's about analysis, we want you to quantify the information that you're getting and making sure. It's basically that whole trust and verify thing. So we give you a bunch of statistics out the box. All the statistics are either on the charts themselves through trend lines or R-squared values, including the work necessary to see how we achieve the R-squared. The formula is actually listed. We give you on the back of the card the counts of all the categorical information, kurtosis, skewness, the whole 9 yards. We give you all the stats on the back so you know that the results are what you're looking for, or you can quickly go back and get something else. It's important that the application allows you to focus on the analysis. How many times as an analyst you have a piece of paper and pencil out at your ready? So every step of the way you're writing things down, right? And then at the end of your analysis, where'd that piece of paper go with that filter expression I wrote? Right? Well, we also considered that in building out Insights as well. And the model, think of every page as you're dragging and dropping. It's actually recording everything for you and creating a model. The model serves a number of purposes. At the macro level, think of it as documentation of how you got those results. So in 2 weeks' time, when someone comes back to you, how'd you get that answer? Just show them. It's right there. Everything is documented for you. But more importantly, if it's a repeatable workflow, you can save the model out as a template. And then you can bring that back into another workbook and re-execute it with a different data set and get the same results. Yep. And Linda, take it away.
Okay, so a few tips and tricks to help you working through Insights. So these are some of the, I'm calling them less obvious features, because I don't like to say they're hidden, because that sounds like we're hiding something. So the less obvious ones. Spatial tree maps. Has anybody found these? See, it's that obvious.
One person did. I see one person, yeah.
So spatial tree maps, what are they? Tree maps, you should probably already know what they are. They allow you to see the amount you have within each category. And it's just going to place it with the most amount in the left-hand side, going over to the least in the right-hand side. But what about if you're trying to talk about something that's on the east and the west, and you're looking at a chart that's kind of the wrong way round? So we've put in this spatial tree map. What you need to do is drag across the location field and another categorical field if you want, and a numeric field if you want. But the spatial one is the one that will make sure we locate all of those parts of the chart in as best as we can to where they are spatially located. So you see in this example of France, the Ile-de-France, which is the Paris bit, is not right in the top left-hand corner, which is where you'd expect it to be, being the largest area, but we've placed it as to where that Parisian area actually is. So they're all located roughly where they should be. Can be very useful if you want to be describing something that falls on a chart and it has location on it. Z-scores. Z-scores are in there. It's not a terribly complex formula, but it's a very, very handy formula, and we've put it in there for you as a simple click. So it's under the Find Answers. That's it, Find Answers tab, which comes off the action button. So what you can do with Z-scores is you can standardize, normalize your data in the way that you can join data together that's of a different type. So let's take population density and a temperature. And you want to derive sort of vulnerability to heat index or something. Well, they're two completely different things, people and temperature. But you want to create that vulnerability index. If you turn them into Z-scores, then you're matching that two data sets. You're taking away that fact that they're different things. You're standardizing those data sets. You can then join them together and make an index from that. So there's a nice little trick in there. So use the Z-scores a little bit more. Chart menus, we've now introduced it. There was always a default. There still is. If you drag and drop it on the chart, it will give you the default, always a sensible one. If you hover a little bit, we will give you a drop-down. In that drop-down, we will give you all the charts that you can create with that data type. Pop-ups. We've added the ability to add a second piece of information. So if you go into what we call the display field, which will be on any of the shape field, location field, coordinate fields, whatever they're called, and you'll see that little icon there, the display field, click on that and you can change it, and then you will get a second piece of information in your pop-up. We also give you what we call the details, so you can see everything when you click on a map, rather than just the pop-up. It's the fourth tab on the layer options, and that's equivalent to the identity button that you have in ArcMap. So if that's what you like, then you can get access to all the information at those locations. So we mentioned about working with dates and how we break it out. Now, sometimes you will already have date within your data. So this is a question I quite often get asked, so I thought I'd mention how we work with the dates. If you drag across something that's year, and this one's shown as categorical, then we will nicely show those years' categorical data in a bar graph. If, however, you have month and it's stored as a number, let's say, so you drag that across, the options you're getting for the chart are a histogram or a box plot because it's numeric. It's showing the number of the month. So actually, when you create that histogram, you're not going to get what you want to get. You want to see how much there is per month. So the little tip there is if you have that, then remember you can click on that type of data set, change it from a number to a string. Now that's going to show it as a bar chart, and now you've got it ordered correctly. If, however, you have your own data and you have it by name of the month, we're not going to sort that correctly by name of the month if it's your own field. And I'll tell you why, because there's an awful lot of languages in the world. And we can't sort them on every single language. So us breaking it out into the constituent parts means that will be sorted for you in your own language we can sort them into the months that way. So that's the way to get everything sorted nicely in terms of your dates and times.
The hidden powerhouse. Ominous, yes. We work with the entirety of the data set. In other words, every time you make an analytic operation happen, a simple drag and drop, I want to create a bar chart, I want to see histogram, we go back to the data and we look at the entirety of the data, regardless of size. And because of that, it also comes back to the technology, right? So working with the entire data set, let's assume you have 1 million records. Okay, great. 1 million records is not that big, or maybe it is, depending on your definition of big data. But we're also working within a browser, and the last thing we want to do is crash your browser. So we actually take steps to guard against that. And when we actually work with this, let's talk about a map for a minute. Currently at 2.3, we actually allow for 50,000 vertices to be shown on a map at a time, times at least 10 map cards within a given page. That's a heck of a lot of information, and we can do that. But keep in mind, I mentioned 1 million records. I want to see 1 million records. Now, when we show that on a map, it's statistically dispersed. So you're actually getting a proper distribution of the spatial information on a map. So you're seeing all of that. But we also give you a little warning sign that says, hey, we are doing this. So you are very aware of it. Now, the way to see all of the data on a map at one time in a browser is to actually use binning. We actually support binning. And you have complete control over, yes, I know control's an illusion, so let's not go there. But you have options available to you to manage how that binning is being done, whether it's at the resolution or at what scale you actually want to see the points come across during that time. One other key point I'd like to bring about is cross-filtering. Within Insights, and I never quite asked this, how many folks are actually using Insights today? Okay, good, good. For those that aren't, it's really fun to work with. And I'm not in sales, so you don't have to worry about that. But cross-filtering was introduced a few releases ago in addition to the interactivity and selections that we already had. So as you can see here, by simply clicking a button on the cards that you want to express the filter against, it'll automatically adjust to the selection. So if I'm interested in an area of interest on a map, I select that area of interest. The cards that are marked as cross-filtered are filtered down to only that selected set. So you can now start doing some great work in terms of understanding your data across multiple dimensions and measures. Last but definitely not least, before I turn it back over to Linda, in the world of GIS, traditionally, there has been only one shape field per layer. One shape field per layer. And when there's multiple spatial elements within your data set, you'd actually have to create a new layer with that new shape type. A lot of that is duplication, et cetera, et cetera. Yes, we understand. But in Insights, because of the concept of data sets and the ability to work with multiple data sources across multiple engines in one place, we abstracted away the concept of data sources into this data set, and understanding that you can have more than one string, more than one number, more than one date and time. Well, we wanted to treat spatial exactly the same. So now you can have multiple spatial fields in one column. You can imagine a zip code is in there, and I want to see things by zip code, but also have coordinates that have been collected as part of that data. So now I can see the data both by zip code and by coordinates. Not too bad. And in doing so, I can also do other things that we're going to get into in a little bit. But allowing for multiple locatable fields, multiple spatial dimensions in one data set, the door starts to open up to more advanced types of analytics that we're going to be talking about in just a little bit. Linda.
Okay, so we're ramping up the complexity here.
Yes, we are.
So, now we're looking at joining different data sets together. Now, one point here is, you've already heard how every time we're creating things, we're giving you a new result data set. Well, don't forget, those can be used in your analysis. They're not just sat on the side of the data pane. They're actually another data set we've created. So in this example here, I've created two table cards. So I wanted to pivot my data so that I had it by place and by year. So I've got spatial, temporal view of the data and the total number of events that have occurred at each of those. So I want to join those two data sets back together because now I've pivoted that data. I want to join it together, and then I want to join it back to my location. So I'm going to go into what we call Create Relationships, which is the little button down in the left-hand side. And then I can just click on the two layers that will take them into that. It will look for the first field in common, but if you click on that little pencil in the middle, then you will see you have the option to update anything within that join. So there are 4 different types of join you can do. If you're like me and you like pictures, it's colored in little pictures so you know what type of join it is. If you're into databases, it also has the true terminology in database language. You can do compound joins, so you can join on multiple different fields. So this is how you can do something like a spatial temporal join. So in this example, I'm going to join on my airport locations. I'm also going to join on the year. So now I've maintained those 2 joins within my data set. I also want to add in the spatial component. So then I just click on my airport layer, and that will join it back in there. You can just click on the layers in it. It will join them. Or if you specifically want to join one table to another, drag it over to that table in that pane and drop it, and it will do that join to that table. So it's a pretty powerful way of doing joins in there. We can also do something called enable location, which is where we're spatially enabling that data. And you can do that in multiple different ways. So you can do it either on coordinates. So if you have X, Y fields within your data set, you can make that a shape field. You might have address, and then you're geocoding that data by address. Or you may have another geographic layer, a polygon or something you want to join it to, and then you want to do the join by the geography. So this will allow you to create any number of fields, spatial fields within your data set. So how does that differ in terms of what it actually does between those 2 things? Because I've just said that you can do a create relationships, it will join your data, or I've said that you can enable location, and that will join it to another geography. So what's the difference between those 2 joins? So I'm going to use the model here to show you. You can see within this example here that I'm doing a join between my zip codes and my accidents and vehicles. So that will then give me a data set, and you'll see here under the locate, if I'm done enable location, then that will just update and add me a new shape field within that data set. So within this one, I have coordinates, which I already had. I then did enable location. It then gave me a shape field for zip code. If I, in fact, do a join through the create relationships, I will also get those 2 shape columns, because one had the zip codes, one had the coordinates, but the one that had the zip code information had 4 additional fields that I didn't have in the first one. So that's the difference you're going to get. Enable location will simply add the new location from the other data set. The join, the create relationships, will add the spatial and any additional fields that you have in both of those data sets. All right. So we're going to go into some of the more advanced methods that we've introduced more recently. So the first one to cover is regression analysis. So we now have ordinary least squared regression in Insights. There are 2 different ways that we can use regression in here. You can use it to explore the data, and you can also use it to predict the data. So under the Find Answers tab, or even from the Action button, you can go in there, create your regression model, and you can select the layer. You obviously select your explanatory variables. You can visualize those through a scatter plot matrix. You can create a scatter plot matrix without doing regression. It's just that we put that little button in there because it's kind of a part of exploring your data when you're doing regression. So you're able to see the R squared on any of the little scatter plots that you've made. If one of those scatter plots is something you want to drill into a little bit more, you want to understand a bit more about it, click on that scatter plot, drag it out. Remember, everything in Insights is interactive, so just drag out that scatter plot. It will create a new one, and then you can add on the trend values and stuff if you like to. If you press Run on the regression, it will run the regression model. It will give you the R-squared, the adjusted R-squared, and it will also run the Durbin-Watson test, which will allow you to assess at the end of it which are the better models you have, because you can run a number of different ones. You can then, once you've created that function, so what it will do when you've run that model is in the data pane, in addition to data sets that we add, we're now going to add something called a function, which will show you those model statistics in that data pane. But what you can actually do is pick that up, drag it over to a map, for example, and that will then predict to those other locations using that model. If they have different fields, just update the fields, and it will use that regression model that you've created to do a prediction to that new data set. So it's as easy as that. Link analysis, another complex analysis that we've started to add in, so we spend a little bit of time on this. So link analysis is actually a very old style of analysis, way back from old social geography. More recently, it's been used within a lot of sort of crime analysis to understand who the bad guys are. But I wanted to take a little bit of time to express how many different ways you can use link analysis. It's really about understanding what is the most important thing you have in the network. It's about relationships between people, objects, places, and events. Any type of entity, in short. So we could take it in terms of lines of communication. That could be in business, in crime networks. Who's the person who's the most important? Maybe the person who gets all the phone calls. It may be the person who makes all the phone calls. So that's whether you have an inward or an outward direction. It may be that you have some kind of transmission lines, water lines, electricity lines. You may have key nodes in there, so towers or junctions, that if that fails, a lot of people downstream of that are going to be affected by that failure. That to you is the most important thing. It may be a road intersection or a bridge that if it breaks down, a lot of people are going to be cut off. It may be an evacuation route. You can't allow that to happen. It may be something like servers that you have. Which is the server that's most likely to get the biggest load, and therefore that's the one you're going to spend your time keeping an eye on. It could be distribution centres that you're sending things out from, catchment areas of people, epidemic diseases, transport routes, all sorts of different things. So it is very useful to understand these relationships within your data. So one key thing to explain to geographers is, although we're talking about network analysis, it's a graph network. So what that means is it's about counting the number of steps between each node, not counting the distance between each node. So in this example here, we see that there's one step between the small node that's furthest away and the next node in is 20 miles away. But in graph network properties, that's one step. I'm going from one node to the next node, it's one step. For the other node that's 3 miles away, it's still only one step because it's one node to one node. I mean, it makes perfect sense if it's somebody making a phone call. I don't care how far away they live, or even a server. I don't care where the server is placed. It's just important for us to understand this, that it's topologic distance we're talking about, geometric distance, not real distances. So there are lots of different ways in which we can calculate what's important. So there are different things that define importantness. So we have these different metrics in there that do the calculation for you. What that means to us when we're using it, the calculation defines the size of the node. So a degree one, the important nodes have many connections. So this is just showing it by the count. This is very simple. What we often do is we actually normalize those so you see the count based on the relative number of nodes that you have within that network. So now you see the numbers change to the normalized one. I've already mentioned with degree that there may be directionality. So you can see whether there's more central or, what's the word?
Prestigious.
More prestigious. Wow, that's a big word. I was feeling smart that day, wasn't I?
Yeah, I didn't write it. You did. I like to keep it simple.
I must have seen advanced in the title and thought, I'll use big words. Betweenness. Important nodes are connections in the network. So they're like key people who keep things together. So that's how that one's calculated. So that would be something like epidemic diseases. You might be interested in that one. Closeness. Important nodes are close to each other. So they're the ones that are the closest to each other. Eigenvector is actually a little bit of combination between them. So the important nodes are connected to many nodes that also have high scores. So that's a much more complex algorithm. It also requires a few more data points, that one, so you sometimes will see that it's not able to complete that. You'll still get an answer. We won't error out, don't panic. But just to let you know, that's the most complex one, so that takes a little bit. So just to show you with the same data set, so these are the different calculations. You'll see that they do give you very different results. If you look at it a little bit, because what you're doing is comparing the size of the nodes, where you actually see very big differences between each of the calculations is actually what's giving you a sign that there is something very different. Because otherwise, very often, importance is shown similarly with each of these different metrics. So where you see something very different between the four metrics, there is something going on in that data set. So that's looking at it non-spatially. That's just creating charts of it. We can also do exactly the same analysis, the same link analysis on a map. Of course we can. We're spatial. So the maps are very important. So that allows us to create spider lines or desire lines. That's showing the straight line connections between origins and destinations. And remember, we're also showing the size of the node based on all of those metrics. You can turn off the metric. We do have the option of none. If you don't want to use the link analysis and you merely want to show the connections, you can do that. In many cases, you will actually want to show some kind of flow of movement between these things. So you want to be showing a flow map. You want to show the amount that has been. So the amount of goods that's being transported, the amount of people who have migrated. So in that case, you want to be showing some sort of sense of movement as well as the volume. So we can do that if you click on something called directional within the data, then that's going to put that flow on there. It's going to curve the arrow, curve the line, it's going to put an arrowhead on there to show the direction of flow within your data set. So link analysis is fairly complex, and there's a little feature in here that we've made the legend itself completely interactive. So this is the thing that you want to play with. So when you open up that legend and you click on any of those components, be it the nodes, be it the line in between, you will see as we're clicking through this that the bottom of that menu is actually changing. So it's changing to meet the component of the line or the node. You have total control how you classify it, how you color it, what it represents, but it's just clicking on those features in that legend that allow you to have that control.
What do you say we stop talking and start showing?
Okay.
Let's do an analysis.
Doing it.
See, in the intro, she actually did analysis with rodents. Now she's doing it on the Ebola virus.
Yeah, that's the difference between introduction and advanced.
Yeah, but could there be something more cheerful next time?
No.
No, I didn't think so.
No, I like to make it look really serious, like I'm doing something terribly important. So here I am with my Ebola cases from the WHO, and we all know how to bring in data into Insights, don't we? I'm not going to go through that. So I'm going to expose all my data, and then we can start to analyze that. Let's have a look. Let's open this one, which I've already made spatial. So I made it spatial by joining those two data sets together. It doesn't have to be spatial for me to start working with it. You can see all the cases that I have within there. I can also scroll down here. So this is an Excel data set, I should say. It's an Excel data set that I just brought in. I joined it to my countries. You can see all the countries that I have there. So that's why I have polygons within there. I'm going to work with the date field here. So let me do it on the non-spatial data. My date fields. So I can drag that across. I can create my time series, which is essentially my epidemic curve for anybody in here who also does epidemiology. You can then view that by country. So one of the points to show here is, no, I changed it to country. I want it by country name. So now you can see the breakdown by each of the individual countries. So I can also make this data spatial. So you've seen how I've joined it already because I've given it away to the country. Because you saw when I dragged and dropped that created my polygons because I joined it to this data set. But I think I also have in there X and Y coordinates. So let's just see if I have. Yeah, look at that. I have my X and Y coordinates. It's already found it. So now I can spatially enable that so I have both polygons and points within exactly the same data set. So this will just take a little minute because there are quite a lot of points I have within this data set. Unfortunately, there were a lot of cases of Ebola. So this is across all years of Ebola they've ever had. So now I'm going to drag this location field and you will see that that will give us points. No, I dragged the wrong one. Operator error. There you go. Then that will give me points. There we have it. Come on.
Database thinks it's the end of the week too.
I know. Well, we can come back to it. I've got so much to show. Let me get to the more exciting stuff anyway. So this is another data set that was actually collected out there. And the person who collected it was able to collect all the information as to where people were actually had the onset of the disease, but also the places where they were buried. So this is quite an exciting data set for somebody like me who can explore this. And what that actually showed by plotting these two locations, because I had the grave locations, I had where they had the onset of the disease. So I could plot both of those points together, but also dragging the two fields together means that we create these flows between them. So that's automatically how we'll do it. If you drag two shape fields together onto the map, is how you'll get that flow map. So now you can start to see that out here in the rural areas, where they had the onset of the disease and where they were buried was actually pretty much the same location. You go into the more urban areas, particularly down here in the main city, you'll see what's happening is, of course, they were taking that body probably back to where they used to live, the village. Makes perfect sense. That was what happened. It's an epidemic disease that we're asking everyone not to touch the body. So this was a really interesting pattern showing that flow of the bodies traveling out across the country. We can also explore it over time, so obviously we can see those patterns. I'm going to jump to this to show that. So this shows one of those flow maps. Let's start way early in the epidemic. So you'll see that I have the cross-filtering turned on here. I have my data clock that's showing the relationships. Where we're seeing the loop here is where they have the onset of the disease and also the same place where they died. So we're seeing this moving through the different times. I'll skip a few, but what you should be seeing as this is going on is how you're seeing more and more links between the locations as the disease is traveling through each of these different towns and cities, and that's how the spread of the epidemic is happening. Of course, it's very easy to look at these things post, but what they're trying to understand is at the start, which one of these are the key regions in which these diseases are occurring. So in terms of actually touching the body, we could take it a little bit further because this is actually broken down into who they actually touched at funerals. And then from that, we can start to see who the key person is. And of course, everything is related back. We have all our links between all our charts. We can see who the key person is, who they were touching at funerals, and therefore who might be we need to talk to in the different areas. to change patterns that are going on. We can also change how we visualize that data, so we can see a hierarchical structure to see who is maybe the most important person. And obviously we'll say the mother is the most important person. You'll see how that then jumped her to the top of that tree. And now we can explore down there as to the patterns that are going on in this. So you can imagine if all of those different things I've talked about at the start, if you want to just see the most important thing, you can quickly pull that out. You can also get rid of sort of edge nodes. You can filter all that information out. And of course, we can see everything that I've done behind the scenes with our models, so everything is there. Have I covered everything?
I sure hope so.
Okay. Let's call that done then.
Yeah, you're done. Oh, I thought I had a few more minutes.
Oh, do you want me to do something else?
Nah, I think we're good.
All right.
All right. Yep. All right. Now that we've kind of seen the analysis, we really got to get Linda working on something a little more cheerful, though. I really.
Somebody gives me some happy data, and I promise I'll use it next year.
But it's kind of important. There's so many different types of analytics inside of Insights. It's not just about simple analysis. The way we like to think about it is powerful analysis made simple. And the application of the analysis techniques that we have exposed are applicable across a number of different tradecraft or industries, if you will. So it's kind of important to know that that's how the Insights team works. It's not just we throw a piece of analysis in there and it's designed for a given workflow. It's designed for a myriad of workflows so that you can take advantage of it in a number of different ways. So in terms of coming soon, we have a near-term coming soon and a longer-term coming soon. And it's important to note that the way we do releases for Insights, we try to keep it to 8 to 12-week schedules. Like I mentioned, Insights is 17 months old. We've had 9 releases already. It's in both enterprise and online, and we kind of try to keep both online and enterprise capabilities and feature sets equivalent across the board. There are rare cases where we have to say it's coming soon. It's kind of an engineering promise to our users saying that we are working on it and it will be there. But in most cases, everything is pretty much across the board even. So in terms of coming soon, I'm meaning September. We're tying it to the next ArcGIS Online release because there's a few things in the infrastructure of online that we've had to change, and we had to coordinate our release schedules.
And if anyone was watching carefully, I was showing the latest version.
Oh yeah, that's right.
So there was a few little sneak peeks in there that you will have noticed.
Yeah, she tends to do that from time to time. New features. Another key thing that I wanted to point out is we don't actually plan the next release until we're about 2 or 3 weeks before we start the release. So just as we're ending one release, we plan the next release. Within 2 or 3 weeks, we start the following release. And that's an important fact because we actually want to hear feedback from our users. And again, being agile and game thinking, we want to make sure that we're agile enough to reprioritize as is needed based on the needs at hand. So in terms of new features, these things came directly from our users, like changing unique colors. Yes, you could have done that earlier, but they wanted even more control over colors. So even down to the legend level on a unique value on a categorical piece of information, you can change the individual color with color ramps. On calculate field, we heard loud and clear that it was a little confusing mixing all the functions and fields in one drop-down list, even if we had the quick IntelliSense to search through as I'm typing. So we even took it the next level, kept that in there, but broke the fields and the calculations into 2 separate columns and gave you IntelliSense so you can start working with a formula, know exactly the parameters needed for the formula, and as you're typing, the highlight will show you the parameter from which you're currently working. Although our filters are good, you know, people keep wanting more, and that's fine. And guess what? They wanted expressions. They wanted to be able to type in full-on expressions against their data. And more importantly, they didn't want to have to learn new technology. This was heard loud and clear. Some folks asked us, well, why didn't you use Arcade? How many people know how to use Arcade? A couple of 3. But how many people know how to write SQL expressions to define their filters? A heck of a lot more hands go up. So it's more of a, let's try to eliminate the technological gaps and allow the analyst to focus on the analysis rather than learning all new technology all the time. So we made a conscious decision to keep it at the SQL level so you can type advanced square expressions dynamically on the fly. And here's one of those engineering promises I made mention of. One of the gaps that we have between ArcGIS Enterprise and ArcGIS Online is the ability to share my insights pages publicly, right? Heard you loud and clear. We put that coming soon on there. That's our engineering promise. It says we're working on it. And this is why, this is kind of like why we had to line our release up with ArcGIS Online, because behind the scenes, we've implemented a caching scenario such that we dynamically handle invalidation, delta changes on transacted data, the whole 9 yards, and everything is running from memory as much as possible in a shared read-only mode. However, we identified the performance improvements of 2 to 3 times simply by doing this. So we figured out also how to do this on the workbook itself during your analysis process. So by making this one change, keeping our promise to enable it in online, we also achieved more performance even during the analysis process, and that is coming in September. Now, we tried all week long to get this little word out there called Analytic Journals. Does that resonate with anyone? We got a couple of heads nodding. But for the most part, most people don't get it right away. But if I say interactive reports, people get it right away. We're trying out a couple of ideas. So think of this as analytic journals or interactive reports. When today you share an insights page, it's kind of bland. You get the cards, where they're positioned, and how you set up the interactivity, whether it's a selection set or a cross-filtering scenario. Well, we wanted more on there, and so we've done that. We now have full control over the assets on the page. You can set the page color, the borders, marginalia, the whole 9 yards. You can even specify, if you wanted to print, guidelines for the print size that you want. So you can position everything the way that you need. On all the cards, you now have options available to you to change the grid outlines, the colors of the cards, the axes labels, the different titles on there. Background color, foreground color, the whole 9 yard is now available to you as part of these options. Now, what good is a report if I can't brand it with my own logo, right? I want to brand it with my own logo, my own color scheme. Well, guess what? We added new widgets in there. One widget is known as the rich text card, and the rich text card allows me to do a whole bunch of things. One, add descriptive text around the information so I can provide descriptions in my report, so as people are using it, they can do some nice things there. I can add images, I can add video, I can add URL links, I can add a whole bunch of stuff just with this one rich text card. Another card that we're adding as a widget is a KPI card. KPI card meaning key performance indicator based on categorical or numeric information, so I can provide some min, max, average, or even counts distinct on those key performance indicators. But I can also optionally set a target value in a gauge form, so it'll actually tell you whether you're over or under your target based on that KPI that's coming in. Ultimately allowing me to achieve something that looks nice, that makes sense for my information, for the story that I'm trying to tell with the results that I created. Now, more importantly, what you created can be saved as a theme or a template so that I can simply save it out as a new portal item, and on any other insights page I can simply pick that theme and it'll automatically place the cards where you've left the placeholders and create the report dynamically based on that theme. All this is coming at 3.0 in September. Now, I mentioned something about not planning too far ahead. So everything that I'm going to be talking about here is pretty much 6 to 9 months off. Can I safely say that, Linda?
Yeah.
All right. Well, Scott's not here, so I don't get my hand slapped, so it's good.
Right, you're good.
All right, so the roadhead.
I won't snitch.
Thank you. You guys got to keep that too. Don't tell anyone I told you this. All right. One key thing we keep hearing about is extensibility. we know we're not going to be able to support everything that everyone wants, right? Like more data connectors. I want to connect to Amazon Redshift. I want to connect to Azure's Data Lake. I want to connect to whatever, my MongoDB instance. We're going to continue adding more data connectors across the spectrum of data sources like relational data systems, NoSQL data systems, GPU data engines, analytic cubes. I can go on down the line, graph engines, document databases. We're going to continue expanding our offerings. But we also want to make that extensible, not only for enterprise customers that want to simply make a connection back to Access. How many people use Access databases? There's a few out there. I know you're out there because it's our #2 requested data source. Yes. And mostly coming from local and state government agencies. But keep in mind, we're allowing that, in addition to working on additional data sources. Custom visualizations. We know that there's a plethora of ways in which you can present your data, and what we're going to be doing is open sourcing this API so that you can create a community of visualizations that you can just download and plug into Insights. So if you wanted something crazy like, I don't know, candlestick chart, you can write it, plug it in, or grab an open source piece of code, implement the JavaScript API on it, plug it in, and it'll just start working. How many people write Python and/or R? Okay. A lot of people are asking for that as well, and we are going to be integrating Python and R both inside and outside of Insights. ArcGIS is adding a whole bunch of new Python and R integration with Jupyter notebooks going forward. We'll be able to take advantage of that, but more importantly, inside of Insights, you'll be able to write a quick functional script to do something against the data set on a card or even against the data pane, either in Python and/or R. Those are coming, and that also gives us the ability to do custom analytic operations. So if you wanted to add something from, I don't know, a Py package or something like that, you'll be able to add that dynamically on the fly, execute it as part of your model, and away you go. These are just some of the things that we're working on actively right now. Going forward, analytics. Of course we're going to be adding more analytics. We had our first Insights meetup last night. We're starting a concept of an Insights Academy, I think Doug is calling it. Basically, a community around analysts. We always hear about communities around developers, but what about us analysts? Well, guess what? We're starting that community, and it's going to start spreading nationwide. And we even talked to Canada and the UK, and they're interested in creating these user groups as well. So you're going to start seeing more and more of this. However, we heard loud and clear, everyone wanted more temporal analysis. They wanted clustered analysis. They wanted segmentation analysis. Anyone from DOTs out here? 1, 2. All right. Well, we're going to be adding those things. And we're going to continue to make it easy to use on all the standard analytic operations. Insights is designed to allow a speed of thought style analysis process within the experience. We're not going to change that. We're going to continue evolving that experience. And I've already mentioned more data connections. You got to keep in mind that data becomes more and more complex every single day. How many folks have a smartphone? There's a ton of data being collected on these smartphones, and you see it every time you visit an Amazon page or Netflix. I'm figuring out movies I didn't even know I liked. They're telling me I might like them. But nonetheless, there's a lot of data being collected, and like we said, here's the data, now go do that data science-y thing, right? We need to allow you to have access to that data, leverage the data in the same way to perform the same analysis regardless of where it comes from, and that's one of our primary goals. And real-time analysis, stream analysis. You can imagine I have all this IoT thing going on where I've got machine sensor information coming in. Today we do it with GeoEvent Server. We're collecting information in real time. Well, Insights will be able to stream that information down, and you can imagine a chart that you created based on an analytic operation, a drag and drop. Well, as the information comes in, that chart will animate over, keep the historic information, and then render in an animated way the new information. And then you can pause it and go back in time and replay it. Wouldn't that be cool? And then put that out there as a report, and away you go.
I'm just hoping we're going to run out of time soon, because otherwise I'm going to have a lot of work to do in the next year.
Oh yeah, you definitely will. And there's a whole bunch more. I have 3 active research projects that take us even further that I'm going to avoid talking about right now because she doesn't want to. All right. Anyway, the key thing for the Insights team is we want to hear from the analysts so we can better prioritize the types of analysis that we include in our product. Keep in mind we're trying to build things quickly, but at the same time we want to build the right thing. And the way the Insights team works, we don't plan until we're just about ready to start the next release after we're almost done with the current release. So there's plenty of time to reprioritize and jig things around based on your needs. So as you begin working with this, as you continue working with this, do you find something that's just, this doesn't work right for me, I want something different? We want to hear about those things. Ideas website, the GeoNet website, talk to the account manager, work with our product manager. Fortunately for him, he's not here. His name is Scott Sandusky, though. ssandusky@esri.com. Work through those channels, get us the information, and we'll make sure to prioritize things. Last but definitely not least, there's that survey. Gotta ask you to fill them out. But I do think that's all that we had in this hour. We do have 5 minutes. If you have any questions, we're more than willing to take a couple. All right. Well, we do have a question. Yes, ma'am.
There is a maximum size for the data sets.
Is there a maximum size for the data sets? Which data set are we talking about? Coming from a relational data system, Excel, which?
MongoDB data sets.
Well, Excel has a limit of 1 million records. So that's not a problem. We can drag the whole 1 million records in. In terms of working with a relational system, there is no maximum size. It depends on your system and the amount of data that you have. So we're trying not to make limits on anything, but take advantage of the infrastructure that you have and the data sizes that you have. And it could be short and wide, or tall and long. It doesn't matter. We'll work with it all. You're very welcome. Yes, ma'am.
Good. So at the moment, our link analysis, it won't give you a new data set. We'll simply show you the results of it. We are working towards actually outputting some kind of result. It's actually pretty complex because normally for link analysis, you'd be working in triples. So you have the from to and then the connect to the link between the two. So we're having to be pretty clever working with relational data to get it to do that. So it's definitely on our roadmap. We will try and get it in for September. If we don't, it will be in the next release.
However, the centrality measure will be exposed as part of the link chart or the link map so that you can filter on it and do other types of analysis against it. Yeah. We are, in fact, building a graph on the fly from any type of data from anywhere. That's exactly how we're doing it. So it's kind of important. All right, with that said, thank you very much for coming. Hope you enjoyed the week.